Hello, everyone. Welcome to another episode of Wavelengths, an Amphenol Broadband Solutions podcast. I'm your host, Daniel Litwin, the voice of B2B. And folks, thanks so much for joining us on another episode of ABS's show. We appreciate you listening along for some industry thought leadership today. And as we explore today's topic, make sure that you're heading to our website, amphenolbroadband.com. Again, amphenolbroadband.com for more information on the trends, technologies, and topics we're breaking down today, but also for more ABS content, including episodes of the podcast. And if you'd like audio versions of the podcast, you can find those on Apple Podcasts and Spotify. So just hit that subscribe button, and you'll have a full catalog of previous conversations, plus notifications when we drop new ones. So, on today's episode of the podcast, we're going to dig into the domino effects that are currently shaping 5G's expansion and its necessary ecosystem of technology. There's been a lot of recent news around high-profile 5G use cases and advancements as of late that continue to inspire the IoT-enabled cities and businesses of the future. Examples like Verizon's Thor, which is a mobile 5G first responder hub built into a Ford F-650, or Google Cloud's latest 5G services expansion with their Ericsson partnership, where they're developing new enterprise edge cloud services, and all of that on top of telecom companies continuing to build out their 5G networks in the United States. However, regardless of 5G's industry reach, from automotive to medical to retail, all successful 5G deployments are going to need to interface with an array of IoT devices. And to do that, 5G and IoT networks both will need the right supporting technology to not only build out that ecosystem, but also to maximize data flow and operations. So with our conversation, what we're going to be doing is breaking down that tech ecosystem, focusing mostly on how connector and antenna solutions will support the future of 5G-enabled IoT. So for insights, we're joined today by Dan Gorsage. He's Director of Sales and New Business Development for Amphenol Mobile Consumer Products Group. Dan, great to have you on. How you doing today?
Great, Daniel. Thanks for having me on your podcast today, and looking forward to the conversation.
Yeah, man, it's a real pleasure having you on. We've got two Daniels, which means twice the fun and twice the thought leadership. So looking forward to breaking this down with you. Thank you again for joining us. Let's go ahead and jump right in. I want to start pretty big picture here. Can you give us an update on where the most exciting deployments are today that you see intersecting 5G networks with IoT-enabled devices? And by where, maybe which industries or use cases specifically are you seeing intersect those two worlds well, and why?
Yeah, that's a great question to kick it off, Daniel, because I look at this as 5G and a little bit of history here. If you think about 4G, or even going back to 1G, if you will, it's about a 10-year evolution from the time that things really start to build out. And every 10 years, if you look back in this history, and even to 4G in 2010, and we hit about 2020, and we're starting to see that 5G deployment by various spectrum. And when we get into kind of that technical side of this, I don't want to be too granular here at this moment, but just to say, spectrums are either licensed, they're unlicensed, some are private, public, and some combination between the two. So as all that builds out, I kind of liken it to, we still have an infrastructure in place, 4G LTE, in fact, and we want to enhance that and augment it with this next generation 5G. And I kind of think of roads and bridges today. We're still using the same roads and bridges, but we're just going to build more. We're going to have more highways. Some are going to be ultra fast. Some are going to be used only privately, this kind of thing. So when I liken it to that and where we're at, when the whole 5G comes together with the International Telecommunications Union, 3GPP, the partnership to create this next generation of communications, they kind of segmented into really three arenas. Enhanced mobile broadband. You have this ultra reliable machine type, which is very low latency, very quick to react, and then this massive machine type. So if we break those three into this 5G, we can really only say today that we're really at the enhanced mobile broadband segment today, which enables these cellular phones that have been announced into the market. There are several in the market today, and some of the fixed base routers of today. So when it starts to cross-sect to IoT, I think we're still in that early stage of seeing where IoT intersects this space, but it is coming for sure, Daniel. So looking forward to what happens next there. Maybe another point to the IoT side of this. When I think of IoT, I think of also a hardware kind of piece to this. You have sensors, you have antenna, you have connectors. And the segment that this passes through would be from some device, whether it's wearable or out in a field somewhere, passing through some gateway or a hub, and then finally ends up at a data center where it's going to be analyzed, all the algorithms come through, pass back through, and give some intelligence to that, whether it's artificial or direct intelligence. And so the intersecting of this 5G and IoT, I look at them kind of side by side a little bit, but there's certainly going to be that integration. And where Amphenol plays in all this really are all those segments: sensors, connector, antenna, and in the backhaul data systems, we're making cable connectors, fiber optics for all of those kind of use cases. So anyway, I would just say to the answer, it's still coming. There are a lot of cool things that are on the drawing board and in customers building out their IoT ideas. But really, mobile phone and the fixed base wireless really still kind of leading the pack at the moment.
You've laid out almost all of the core pieces that we're going to dig into a little deeper today. So thank you for that intro and that laying of context for where these two worlds are intersecting. I also want to quickly highlight the transition from 4G to 5G because I think maybe there's a misconception that smart city deployments and IoT networks at scale are going to need 5G to expand. And what we're seeing actually is that 5G and IoT are evolving and innovating in separate paths, and then as they're evolving, they're intersecting along the way. Really, the reason I bring this up is because we already saw IoT networks taking advantage of LTE as well as robust Wi-Fi to interact. And so I'm curious how the shift from 4G LTE networks to 5G networks has maybe put a strain or created new opportunities on the connectivity infrastructure that supports IoT today. What are some of the dots to connect there?
Yeah, and if I look at what the promises of 5G will be, because, as I said, still early stage of evolution of this whole telecommunications paths, new roads, I'll call them, but we think of them as wireless roads. A lot of the same bands that are used in LTE today are the very same bands that will be used in 5G and maybe layered a little bit differently. I look at it in this sub 6 gigahertz range, or really even up to 1 gigahertz, and then maybe 1 to 6. And then you have this what is coming millimeter wave. You'll hear that term, I think, out in the markets as above 6 gigahertz. And I think when we see LTE centered that 6 gigahertz and below, there's a lot of that use case that is still similar. Just a few more lanes were added for 5G. And I'm simplifying, but that's basically it. And then the other is we still have Wi-Fi and Wi-Fi 6, which is out in the market. I hear something like 8 billion unique Wi-Fi gateway locations around the world, 8 billion already sitting in place. And now to add that piece to this, maybe the need for 5G in certain use cases, because we have Wi-Fi 6 coming, which is another communication path, wired. In some cases, again, wireless in the home. But you'll have these various overlaps where maybe use case for 5G in those ultra high spectrums of frequency spectrums, really not necessary because we have the paths or at least the use cases for those. So, maybe there's going to be cases where both end up being a very good use case at the same time. And so I could see in the home, you could, as you mentioned, maybe it's the smart city paths. But the one thing about 5G in this high spectrum or high frequency spectrum, it's really, really short range. And because it's short range and such a high frequency, it's really line of sight. And so thinking about antenna for those applications, you're going to need maybe 10, 100, 1000x to cover a certain area because you need the line of sight and because of the distance that it can only travel. So smarts to those type of antenna will even be more important for in-building, outside building, and then transmitting to whatever those IoT devices, whether it be a handset or some item out in a field. So you can think about to deploy that kind of high frequency spectrum in rural areas, for example, may be very difficult. And therefore, 4G LTE systems work just fine. So
naturally, with the expansion of 5G, we're going to see data flow as well as data storage needs increase in scale. So I'm wondering how you see that influencing the correct strategies, right? How should tomorrow's, or really today, it's because it's happening in real time, how should the 5G IoT solutions of today and tomorrow approach building consistent technology ecosystems that can support these higher bandwidths and speeds? What really needs to go into that in your view?
Yeah, so, thinking about device side, because that's kind of where I live most of my life on the device side, especially embedded antenna. The thing about, as all devices, you want to be able to communicate across multiple types of mediums, whether it be Bluetooth, you want Wi-Fi, you want GPS, you want all the other characteristics that you have today, even over the cellular network. But now you want to add perhaps this millimeter wave I mentioned before, because maybe this device now takes the place of your HDMI cable, for example, communicating to your TV. You begin to lose wires. One other area here that is a little bit outside the boundaries of IoT and 5G, but it's really part of these devices is possibly, it's again battery life. And does the battery, because you have this much more efficient network, doesn't use quite the battery power that you need to these devices. But in some cases, you may still have to charge them. So wireless charging is still something that goes into some of the devices that you're carrying around daily versus maybe some of those IoT devices that are out remotely and monitoring with the sensors, et cetera, bringing that information back. So the complicator for this is how to pack all that into the devices that someone might want to be using for various applications and not cause antenna detuning or sensitivity. We call it isolation between all these bands, because sometimes there's multiple of the same antenna. A device that had 8 antenna 5 years ago or even today probably will have 3x the amount of antenna in each device. So you have to embed that, make sure they're not all cross-talking and causing confusion inside the device, as well as still communicating properly outside. So that from a device side. I think from the network side, have a lot of different, I mentioned before, now we have maybe 100 to 1,000x more antenna needed for repeating these high frequency signals. But at the same time, maybe connectivity isn't as complex. It's just the handoffs, and that's back at the backhaul or somewhere within the network system to handle all of that. So high speed interconnect, certainly, and even more ruggedized type of an interconnect that are out in the field today than even before to handle those very sensitive signals. So I would say that the complexity, you got ruggedization, and then you've got multitudes of all of this data and or power to deal with in these, whether it be on the device side or on the network side.
So you've done a good job of introducing, at least at a high level, some of the technologies that are supporting this ecosystem, including antennas and connectors, which is what we're really focusing on today and where ABS can really shine in this ecosystem. Not to downplay the other set of technologies that you also offer, but we're just going to focus on a few because, hey, it's only one episode. We'll have to bring you back on for follow-ups. But if you could just kind of at a high level hit on that array of technologies, or at least the ones that you can speak to that you think really need to be taken into account to maximize these 5G IoT deployments. So not the core technologies, not really network infrastructure, but the ones that live more at the periphery that help support that core network infrastructure. And then where do you see antennas and connectors also fitting into that ecosystem?
Yeah. I'll see if I can answer some of that anyway. And I
Sure.
look at, because I am an antenna guy and part of the antenna group here. But so one example I can definitely give for some of these, again, high frequency, I keep going back to the millimeter wave, which is the promise of tomorrow and where we're not yet there yet for a number of reasons. Silicon. So the semiconductor industry drives a lot of what we're needing to build with, either by system level and or even at the device level. So really deployment of the silicon behind that. And we know that there's things in the industry today that cause, I guess, a number of ripple effects to being able to deploy more faster. But I think it starts at the silicon level, certainly. And then when we build out toward system level, connectors and cables are still a necessary product of that, and how those connectors now need to perform differently. We call it signal integrity analysis on all of these that have high speed in them. And the higher the speeds for certain data flow, the connector now becomes a part of the system. And that's always been the case from system broadband days. But now it's even more of a piece of the link that happens between data flow into and out of the data centers. So we see that construction of those connectors, the materials used, those kind of things. When I think of an antenna, and especially back again to this high frequency, simple as you can't have icing, you can't have snow sitting on top of these. And right now, a normal mast outside, you might have a number of different antenna that you would see up the mast. But once we get into direct line of sight and the need for short distances, you can have nothing covering these. And so we get into needing sensors to heat these type of antenna and make sure that there's no forming ice, forming snow, those kind of things. So those are just a couple of examples. I think there are a number of pieces of this whole 5G and being able to properly keep the system up and running and the network flowing properly. And we talked about power earlier, again, back to grid and being able to service those network locations. So deployment will be a big part of that. So you have to put together a pretty sizable team to be able to deploy the number of antenna that will be required over time. So an investment into those areas is definitely going to be necessary as well.
Now, to, I guess, connect the dots a little bit more between ABS's product design approach and the way the industry is evolving on its own and matching some of those network trends, how has ABS developed and strategized around crafting its antenna and connector solutions to really play their role effectively? Where have you had to make some strategic technical decisions to either be future-proof or really intersect with that 5G IoT crossover? And give us some of the reasoning there as well.
Yeah, Daniel, I'll try to give it from a perspective, again, a little bit more of a consumer products point of view from where I'm arriving from. And certainly the ABS team, with the network of products that they put into backhaul data centers, continues to evolve to, again, allow for more network transmission from start to finish and power requirements. So we look at it from a device side and what's communicating to the gateways and to the data centers. We have to really look at there's still a user interface that people like to hold either in their hand, on their head, it's in their ear. So when we look at IoT devices this way compared to something that's maybe a cattle tracker or something like this or maybe in a farmer who's again looking to figure out for how to properly irrigate their full farm field and all the sensor information coming in from that. So really, we have to look at what's the best antenna for that medium, meaning if we build things in different fashions, and the antenna world is typically a very unique, customized solution by device when there are multiple in place. And so we may use a plastic, we may use metal, we may use some flex with copper traces, we may use a number of other metallized forms to create those antenna. And again, it kind of comes back to making the choice based on the application. No one sock will fit all, because each application, by what else besides maybe a 4G or a LTE, if they went GPS or some other type of communication to happen in this, we have to look at the whole system and then architect an antenna around that. And now just adding these extra layers of new bands that are coming in, both licensed and unlicensed, just makes the complexity of how to design for those kind of devices far more complicated today. So when we look at, what are those kind of areas that are really emerging now, and what may emerge in the next, say, 5 to 10 years. Ultra wideband is now kind of the big piece that is coming into mobile phones, wearables, hearables. And ultra wideband for us really says that, GPS, though good, ultra wideband is even about 10x better. And in terms of geopositioning, in terms of location based to where you are compared to something else in the building. And that's important for the first responders, right? So they can be tracked more closely if there's something catastrophic that happens. So all that intertwines, I guess, is my point, to whether it's going to be in any of those mission critical to the machine to machine or in the enhanced mobile broadband. All that has to still take into consideration. What is the application, and then how do we design specifically around those categories?
Sure. You kind of already gave the answer here, but I want to pitch the question in a different way to see if there's any other insights. But you mentioned how these ecosystem-related products need to be flexible enough to adapt to any 5G or IoT need. And if we had to maybe split into two categories, just generalizing, we see that the IoT 5G future is going to rely on both working with fixed device solutions as well as mobile device solutions. And that can be both at the enterprise and commercial level as well as consumer devices. So do you see antennas and connectors needing to adapt in very specific ways to meet the needs of, a 5G IoT-enabled mobile device versus a 5G IoT-enabled fixed device? What are some of those key differentiators, and why do they matter?
Yeah, that's a great question, because, in terms of devices, and I kind of go back to the mobile handheld, but, again, if it's a wearable, a hearable, but it can be anything that's attached to human, to animal, to whatever, or monitoring something in a parking lot, for example. You maybe in a parking garage, and you're wanting maybe the most aesthetically pleasing device, because, again, not to make it seem so bulky and out of place, but part of the structure. So what I see in some of these cases, especially if it's a body worn, again, those are things that aesthetic, cosmetic, and to make those type of antenna or communication devices small and fitting, we have to find different technologies to make those antenna and fit and work properly. Perhaps in a more of a fixed base, something that's external to the device isn't so bad, unless it's somewhere in a particular area or setting that somebody just doesn't like to see a big whip antenna or some type of external antenna to be shown. But in those cases, you may just need to, just because of antenna performance, you have no choice but to have something external that works omnidirectional, or specifically in a beam directed mode. You need to have that beam hitting directly at a particular location. And we set those angles, we set all of those things in order to make it communicate and work properly all the time. So again, something body worn, aesthetically pleasing, something in the ear, maybe the two, maybe we look at it in terms of use case again, but also, hey, to the human look, see, and feel, you like to see something different and compare it to something that maybe isn't such a necessary. And so we can make those antenna much more efficient when we have a lot more space. We have a lot more room to create the device, and so that's also a luxury when you have more space and area to build upon.
And I think what makes this ecosystem a little difficult to navigate for end users is that it may be hard to, do some self-reflection as a company and really analyze where are we needing these solutions to shine, and how should that reflect in our technology investments. With so many, disparate technologies intersecting with this ecosystem of 5G and IoT, I think it can make that conversation difficult for companies to know where to start and for decision makers to know where to start. So I'm looking to maybe get some strategies from you. What metrics do you think think businesses who are building out their 5G and IoT equipment, what should they weigh to determine the right antenna and connector solutions, for example, or really just any supporting technology? How can they determine what's right for them and their needs, and why?
Yeah, I think it kind of goes back to application need. How critical is that communication? Because when we design, for example, interconnect systems or antenna systems for any particular device or system, we always ask, well, how critical is this? Because again, it comes back to material choices, maybe performance choices that aren't optimal, but good enough. And the good enough, maybe for certain areas, that gives you a chance to say, okay, it works. It'll work fine in this application for my device. So what we often do is kind of pull the customer to say how critical. Meaning, if it's mission critical and you're a public safety or something like this, it's absolutely right. But maybe for somebody who's taking their heart rate once a couple of hours a day or something like this, through some wearable device, maybe not as critical that the Bluetooth wasn't quite working right at that moment, but maybe in 5 seconds later it will. So 5 seconds can mean everything, right, to something mission critical. So I think we look at criticality of application, and certainly, return on the investment. What is it? Are you trying to monetize this, or is it just for customer satisfaction? So if the customer satisfaction is ultimate and paramount for your system and devices that are working within that system, then you're probably going to want the most from the system, whether it be from the connectorization to ruggedization to whatever that may be, and manufacturing lines, for example. And I think about robotic lines and how system flow going through, whether it's producing a product or analyzing a product. We actually do some automation equipment in our group as well. And we look at how those react to the whole system. So the AI intelligence behind that, I would say software will be very important to those, and the user interfaces behind those as well as your network that is controlling all of this. So how much do you want to put into a public based system versus a private based system that will handle that your network? Because if you are sharing, of course, there's always some level of risk there. And the other is, if you went private, you're probably looking for the investment, a little bit higher investment on the front end. So I think you have to look at the overall spectrum of what your market and where you are in terms of use case, like we say. So whether it be for smart energy or smart transport. So again, if it's mass transit and you're looking to add Wi-Fi or some type of 5G to your mass transit system, again, maybe public budgets and all those things come into play. But it's also something to promote within your city. Hey, you come to the city of, and we have. Maybe it's the Olympics coming, right? You come to the Olympics, and when and if those open up for more spectators, that will be a very interesting promotional thing for people to put out that, hey, this is part of what we offer when you come to our facility, or can see when you visit our location.
Yeah, it's pretty engaging that this technology ecosystem is going to be beneficial to businesses, venues, in that kind of external way, right, to draw buzz and attention. And also the more internal, under the hood ways. It really can be leveraged both for its core operational purpose, but also to, give a little boost to the marketing team, which may not be the first, reasoning for why to launch technology like this, but I think should be a deep consideration, because especially coming out of COVID, coming into a world where consumers are demanding a more exciting in-person experience, and they're really wanting to be wowed and sold after adapting to not being at any in-person experiences for a year and a half. I think that kind of technology ecosystem and really evangelizing it is going to be big for not only the companies that use it, but then also just promoting the technology in general, which I think creates positive domino effects for everyone. A little industry solidarity there, right?
I think about the retail market as you just say. We've the brick and mortar spaces that have been hurt so badly during this, and a lot more than others. But thinking about what that experience is to go to an actual store again, and what those experiences will end up being like in this, say, 6-8 years out, and those experiences are going to be much different, and maybe even still holographic in nature if you're having that capability at home with AR, VR. All those things can have the ability to bring more customers to those venues, possibly to say, wow, I'd really like to see this in person now that I've had the experience virtually. Even though maybe it's 2D right now, 3D and those kind of things, and AR, VR will allow for some of those experiences. Or maybe you don't need to go to the store because it's so good. It's such a good experience. So, and I think the stadiums, you think about the mass areas of whether it be for a concert or for a sporting event or whatever, same kind of experiences can happen there and are deployed into those places now that eventually will even enhance those experiences as well. So, I think it's going to be an interesting cascading thing once all of this is really into place, even though it's going to take some time before we see the full fruition. But looking forward to it.
As am I, Dan, as am I. So last thing that I want to toss your way is kind of a bit of a speed round, a lightning round here, where I want to get more specific around how these supporting technologies, right, that sort of periphery of tech supporting the 5G IoT network infrastructure, how those supporting technologies are enabling said maximized network in different industries. So really what I'm looking for here is what are some of the quality connector and antenna use cases that are enabling some positive 5G and IoT use cases in these various industries. So I'll list them and then give us your quick elevator pitch. We'll keep it quick and then we'll wrap up our conversation. So first one here is the automotive industry. So whether we're talking autonomous vehicles or digital services and connection within the vehicle, give us your perception there on how you see that ecosystem of tech supporting 5G and IoT deployments in automotive use cases.
I think that, again, high speed, high bandwidth right to the vehicle, but offloading a lot of that to the cloud. And whereas the vehicle maybe having its own concentric computer of sorts, a lot of this activity will be offloaded to the cloud. And because of low latency of 5G, it'll work very well in those use cases.
Next one on the list is retail markets. You brought these up a little earlier during the discussion, but we could be talking AR, could be talking VR, experience deployments, or just some of the IoT embedded sensors that are providing a lot of valuable data to retail operations. Where do you see the intersection between that ecosystem and retail?
Yeah, I see examples of whether it's going to be facial recognition or some other types of characteristics to know you as the consumer and you are looking at that particular product, for example. But that's just an in-store application. I see the AR, VR world really taking a hold of this space and make it almost as though you have the product in your hand other than physical weight. And so, again, using AR, VR for this application will be fantastic for consumers to, again, do their shopping almost like you're in your car that you want to drive and have that experience of driving the actual car, something like this.
Another exciting industry is the medical industry, or just healthcare in general. We're seeing 5G support telemedicine, telehealth, a lot of remote monitoring, and potentially even remote surgery. So where do you see the ecosystem of tech supporting these use cases?
Yeah, certainly telehealth, with COVID happening and this sort of thing, and having a different type of relationship with your medical professional. Certainly telemedicine. I think the remote surgeries, maybe because of the systems, fiber optic may be still a very viable solution over wireless. But certainly 5G enabling all that through the backhaul. Remote surgery to rural areas where the doctor is only in some of the major metropolitan areas. So I think that the telemedicine will certainly expand through all this just by the virtual nature of being able to communicate just as we are today.
One of the more scaled deployments that we've seen comes from the manufacturing sector, which is using a whole variety of different sensors and AI-enabled machinery today. Break that down for us and how you see the ecosystem supporting manufacturing use cases.
Yeah, so many areas we could go into on manufacturing. I think of one in particular as with sensor, different types of sensors that actually mimic the human. And in this case, we would say if a human were to actually polish something, for example, very high polish need, usually the human, almost out of art capability, has different pressure levels and how they maneuver around. We can now teach that exactly to a machine through sensor technology and obviously some microprocessors. But now all of a sudden we have a robot that polishes something just like the human would. So I see manufacturing taking capability from what is somewhat an art form and teaching those types of activities to allow for greater volume manufacturing and obviously consistency. So I see that at the same time, quality systems will be monitored, whether it be pressure, temperature, humidity, whatever it is in the environment that is needed for that manufacturing line. But then detecting certain types of possible defects that are happening can happen through sound, can happen through other types of an immediate real-time basis. And immediately, technician goes out to the floor to make the correction, or at least maintenance is upkept on a very regular basis. There are whole varied applications behind that for sure, with Industry 4.0 and now scaling it in with the 5G capability and IoT.
Playing off of the manufacturing sector, we've got the large industrial sector. That's kind of a generalized combination of different applications, but we can see, large industrial deployments of 5G and IoT in mass transit, also in major agricultural operations. Where do you see antennas, connectors, that ecosystem supporting those use cases?
Yeah, absolutely. The farming industry, and we see from the ability to not only monitor through sensors of all sorts, temperature, humidity, water levels, all the soil content, all of that driven through sensors and alerted back to the farmer. Maybe don't irrigate today, or yes, you need to irrigate today. I mean, there are a number of areas where fertilizer in certain areas needed or not needed. You see drones out in the field now, literally maybe one master and the rest being drones next to this. So the communication between vehicle to vehicle and then vehicle to soil, soil to infrastructure, or not soil to the vehicles to the infrastructure to monitor the soil and content of and how the plant life is actually doing. And they get all that in real-time data now that before would be, again, farmer in the field and taking soil samples, sending them back, getting some type of analysis. And so all this done in real time. So we can now keep track of what is very important for food supply to the world, right? So, this enhancement to the farmer. And of course, there is some level of investment there. But given the technologies, it should also enhance their full crop line over time. So it's exciting for the farmer. And I think in the mass transit, you also put it well. There are a number of enhancements across communications while you're in transit. To we see antenna, ground antenna up to the airplane now as an example. Rather than it being beamed from satellite. So there are a number of different ways that we can now communicate to even the airline through various antenna capabilities. So all this is all going to continue to evolve and only improve lives as we see it in terms of growth for the farming industry, but also some of the mass transit as well, which again isn't a bad thing.
And last but not least, let's chat massive machine deployments. When we're talking about scale at this size, we're talking about 5G and IoT that has to support smart grids and really high speeds as well as high bandwidth networks. So break that down for us And again, where do you see the ecosystem supporting some of these deployments?
Yeah, and this, again, going back to smart grid a bit here in terms of smart energy, in the home today, you can have your pluggable devices to monitor some of the efficiencies in your home. At a granular area, or say, particular areas that maybe energy can be moved to another area efficiently and through the grid. All this can be monitored through all those sensors that are deployed throughout the system. So I guess the energy efficiencies will only go up, meaning how we scale certain areas for what they're going to be using. Certain periods of the year, we talk about different seasons of the year where, again, in snow, rain, whatever, and obviously during catastrophic periods, right, where a tornado, a hurricane, something like this. So all that deployment is only going to get smarter in how to reassess where the energy needs to flow to. I guess you can look at all the metering that happens, and a lot of these meters are going to, as already deployed as wireless meters. Maybe you still have someone driving up and down the road, or maybe you have it taken remotely, as a lot have already implemented. But even in businesses where the building construction, right from the beginning, whether you're going to be using some type of green energy of some sort, solar panel or whatever, all this still gets back to the network, and the smarts of the network can now efficiently deploy where it needs to deploy certain paths. So I think as a whole, and environmentally speaking, this is only a positive thing as well. Think about the ability to detect leakages in a building or something like this before there's already a puddle. So those are just some small examples. I would just say that efficiencies of detection of something that could eventually be catastrophic later on can be caught much sooner. And the other is just deployment of what we do have and what we are looking to deploy through the smart grid now only gets more efficient because we're able to monitor it real time.
And I think on that note, that does it for our speed round of different industry use cases and wraps up our conversation in a nice little bow. So Dan Gorsage, thank you so much for your perspective today as we break down how 5G and IoT networks are expanding, into which industries they're expanding, and how that is creating positive domino effects there. But more importantly, how that supporting ecosystem of technology, specifically antennas and connectors, are doing a lot of heavy lifting to make sure that these use cases are maximized. So again, thank you to our guest today, Dan Gorsage, Director of Sales and New Business Development for Amphenol Mobile Consumer Products Group. Dan, if folks want to find out more about some of your thought leadership in the space, or they want to get in touch with Amphenol Mobile Consumer Products Group or ABS, the broader parent company, how can they get in touch? How can they learn more?
Sure. Again, you can go to the ABS website for sure, and there's a sales arm for connection through that. And I'm happy to take questions directly if it is something that I can quickly answer. And so, if you're planning to publish the email, Daniel, that's fine for me. I get contacts all the time to do that. But our website is Amphenol -mobile.com. So we'll take a look at, or as MCP goes. So there's a couple different websites that you can look at, and through Amphenol, the corporate website, it does all the breakdown for them as well. So the Amphenol.com website, you can look up mobile and you'll find us.
Perfect. Dan, thank you again for your time. It's really been a pleasure today.
Same here, Daniel. Thank you for your time and the questions, and allowing us to talk a little bit about what we're doing at Amphenol, and in particular some of the categories that we talked about today. Thank you very much.
Yeah, absolutely. And thank you everyone for watching another episode of Wavelengths on Amphenol Broadband Solutions podcast. If you like what you heard and want to listen to previous episodes or stay up to date when we release new ones, make sure that you're heading to our website, amphenolbroadband.com. Again, amphenolbroadband.com, and subscribing to Wavelengths on Apple Podcasts and Spotify. I'm your host, Daniel Litwin, the voice of B2B, and we'll catch you on the next episode of Wavelengths.